Hi guys, today I want to look at terminating decimals. That is decimals that don't recur. I'm sure you've heard of recurring decimals. Well, these are the ones that don't recur. So for example, 0.7 you would know to be 7/10 and 0.13 would be 13/100ths and 0.57 would be 57. So 0.571 is 571,000. Now, what I'm interested in is the denominators. Now, this one is 2 times 5. Now, this one here is 2 times 5, which is 10 times 10 times 2 times 5. And this one, 10 times 10 times 10, is 2 times 5 times 2 times 5 times 2 times 5. So, in effect, this is 2 times 2 times 5 times 5 and 2 times 2 times 2 times 5 times 5 times 5. And the pattern goes on, and for every denominator you've got an equal amount of 2's and 5's. So we can use that in terms of cancelling down. So if we thought about cancelling, and when converting to fractions, if I had 0.12, I could say that is 12 over 100. Fair enough. But if I was to convert that into its prime factors, so I've got 2 times 6 and 2 times 3, using our cherry tree method, I could say that that was 2 times 2 times 3 over 2 times 2 times 5 times 5, and that would be, well, if we times it by 2 and divide it by 2, they undo each other. So we've got 3 over 25, which is 3/25. Let's look at a slightly more complicated one. 0.148. Or should I go for something different? 147 I'm going to go for. Okay, 147. So, I've got 147 over 1,000. If I look at 147, I can see that's 7 times 21, which is 7 times 3. So I've got 3 times 7 times 7 over 2 times 2 times 2 times 5 times 5 times 5. Is there anything there that I can cross off? No. So it's in its simplest form, it would be 147 over 1,000. One more example. 0.320 be 320 over 1,000. So let's have a look at 320. I'll do it up here. That's 10 times 32, which is 2 times 5, and that's 4 times 8, which is 2 times 2, which is 2 times 4, which is 2 times 2. There's lots of 2's. 1, 2, 3, 4, 5, 6 2's. 2, 2. Times 5 over 1,000. And I can cancel them out. So I've got 3 2's, 1, 2, 3, and 1, 2, 3 2's. I can cancel there, or I can do 1 5 and another 5. So what I'm left with here, on the bottom I've got 5 times 5, which is 25. And on the top I've got 2 times 2 times 2, which is 8. So 0.320 is 8 over 25. Now, in order for a decimal to be terminating, if we were to look at a fractions, so if we've got 1/8, is that terminating? Well, I know that that's 1 over 2 times 2 times 2. In order for it to get something that I can manage on the bottom, I'd have to times by as many 5's, top and bottom, which should give me 125 over 1,000, which is 0.125. Now, if I said, well, what about a 1/6, which is 1 over 2 times 3. Oh, but when I look at that, the 3 is not a 5 or a 2. So that means that I can't get this pattern of tens, hundreds, thousands, 10,000s, 100,000s, millions. That can never be there because I can only get those numbers on the denominators by multiplying the same amount of 2's to the same amount of 5's. So as soon as I put a different number in, that's not terminating, because I can't get one of those numbers on the bottom. So it's the opposite of terminating is recurring, and we'll have a look at them another time. So I think I've got space for just one more down there. If I was to do 1 over 80, if I was to look at 80, I would say that's 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. I could say that that was 1 over, and I've got 1, 2, 3, 4 2's, 2 times 2 times 2 times 2, and then a 5 times 5. As long as I've got 2's and 5's, I can make this work. So I've got 4 2's, so I need a total of 4 5's. So I'd have to say times 5 times 5 times 5 times 5, which would give me 4 2's and 4 5's, which gives me like 4 10's times together, which is 10,000. But I'd have to times by 3 5's times together on the top, so it's 125 over 10,000, which as a decimal would be 0.0125. 4 zeros, 4 decimal places. So this is something I've been thinking about for a while, so hopefully it's come across quite well. When you look at decimals that just stop and are not going on forever and ever and ever like pi or something like that, you'll find that they have got a 10, a 100, 1,000, a 10,000, 100,000, a million, 10 million, etc. on the in the denominator. Now each of those numbers is made up by times in tens together, and a 10 is 2 times 5. So 7 tenths would be 7 over 2 times 5, 13 over 2 times 5 times 2 times 5, or 2 times 2 times 5 times 5. And in order for a fraction or a fraction to give a terminating decimal, we have to be able to get to a multiplication of equal numbers of 2's and equal numbers of 5's in the denominator. So within these, I've got 3 2's there, so I needed 3 5's, and I could do that. In here I've got 4 2's and 1 5. I needed 4 2's and 4 5's, so I had to times by 3 5's subsequently, and that gave me my answer. But when I came to a sixth, I found that because I'd got something in there that wasn't a 2 or a 5, that means that that could never be a terminating decimal, because I could never get to 10, 100,000, 10,000. And it also helped me when I thought about changing a decimal to a fraction. So if I go from decimal to over 100, and then think about the prime factorisation top and bottom and then cancelling out, that will really help us get to whether our fraction's in its simplest form or not. Okay, so the whole basis of what I'm looking at here is the fact that a terminating decimal has the same amount of 2's and 5's times together on the bottom, and you can use that to help us with various different bits. Okay.